read this after our class so you can understand, right? Okay, an explosion projects a rock into the air with a speed of 15 meters per second at an angle to the horizontal of 40 degrees. Show that rock would reach its maximum height of about 3 seconds after the explosion. So
Yeah.
the problem is
Uh,
speaking about the maximum height, okay?
yes.
And
I actually it says show the rock would reach its maximum height of about 3 seconds after explosion. I spoke with the teacher and it's a typo. It's just there's not supposed to be the of. So yeah, it's the maximum height about 3 seconds after the explosion.
yeah, but you need to prove this.
Yes.
And we,
Yeah.
we have a lot of the situations that occur in the maximum height, okay? So
Yeah.
the mainly situation is the Vy, our velocity, our speed in y-axis. When you have the maximum height, is because your velocity in y is zero.
Zero. Yeah.
Yeah, because if we have some velocity to up, um, so our hawk will be more to up to sky, right? So now we don't have this. So we can input this information in our equation, right?
Yeah.
So we can now write expression to this velocity, and we know this equation. Final velocity is equal initial velocity more plus acceleration times time, right? So we need define something, some situations here too. For example, we need define our referential. Referential is very important in physics. My referential is here. Okay, here is the initial point of our problem. So here we have the time equals 0 and the position 2. Okay, and we can define too the this how can I say this definition to our Cartesian scheme, right?
Axis.
We can define our axis, our positive axis, to decide to up and to right. Okay,
Yeah.
so if we define to up positive, down is negative here. So we have our gravity negative. A lot of students have mistakes here because they think, oh, the gravity is ever negative or ever positive, but no, this is only associated with the Cartesian scheme here, right? So if we define up positive, so gravity is down, gravity is negative, right? But another thing we need to put in this equation, our initial velocity, because we have a initial velocity here, because this
Yeah.
vector, okay? So
Yeah.
did you know, do you know
Yeah.
what
That's
you need to do here?
it's the for the y, it's v sine theta, and for the x, it's v cos theta.
Perfect. Sine theta. Perfect. So we can put these informations in our equation. So here is 0. Here we have, I need to improve this equation. So because we are in y-axis in this situation here. So
Yeah.
Here we have this, and here I can put the gravity. Now I can put the values. We are speaking about the maximum height, and we know the maximum height is velocity y 0, right?
Yeah.
Here we have v0 sine theta. Here we have minus 10. I suppose your teacher used minus 10, right? Or
No,
9.8.
minus 9.8.
Okay. 9.8. And time, well, here we are searching for the time to prove this information here. Okay? So I will stay with t here, and I will substitute the values here, because we have these values. We have the v0 is 50, and
Yeah.
sine of theta is sine of 40, right? Now we have to isolate the letter t, the time variable.
That's it's
Do you know how do
initial
this?
over acceleration.
Sorry, I don't understand you.
It's the 50s. Yeah, that's what I was gonna say.
Okay. Did you do this math in another time?
Yeah.
Okay. So you are right, because this is the thing here. But I don't know how much is sine of 40. Just a second. Sine of 40 is 0.64, right? Times 50 divided by 9.8, so 3.28 seconds. Well, we see 3 here. Here they said about 3 seconds. Okay, this is about 3 seconds, right?
Yeah.
It's very approximately 3. Okay.
Is
Easy,
that
right?
everything?
It's only this.
Oh, I was doing a lot more.
It's very easy, because we know the path to do this. Okay, in physics we have a lot of paths to do a problem, right, and get your result. But I take the small path to do this, right? Because, for example, we can use force or energy or another equations like Torricelli, like, for example, the equation of the position, right? But the minimum path to obtain the answer is this situation about the velocity. Okay.
Yeah.
So I ever go to the more easy way to do the things, because I am very lazy, right? So I use these situations in my problems, right? Let's go now. Let's go to the next one. Um, we have another similar. The rock
Yeah.
moves in the direction of a hill. The
This
side of the wheel is 20, 20 degrees to the horizontal as shown. Okay, 20 degrees. After a certain distance, the rock lands off the side of the wheel. Deduce whether the rock hits the ground before it reaches the maximum possible height. Okay. Do you know how can we can do this?
I know I don't know how to find out if it reaches the maximum height, but I know a little bit with the slope and that you have to do what's it called? The theta minus alpha, the slope.
Okay.
and that you have to do the gravity cause the slope. And I think that's how you do it. I think.
Yeah, this is a situation, but this problem is really strange to me because
Yeah.
again we have a lot of possibilities to do this. Okay, so I will try some possibility here. For example, we can obtain an equation to this move like a parabolic equation, right?
Mm.
And here we have a linear equation. Sometimes we will have the how can I say the interception of this situation. I don't know if it's the before or after the maximum possible height, but is this a possibility here? But
Yeah.
I don't know. I don't know if is this the more easy way because we are looking this problem in X and I situation, but I can try this problem in X and T situation. I don't know because but this problem is not a X and T because this hill is a, a situation different. But okay, I know how can I do this. I am only think about the more easy way to explain this to you, right? So just a second, just a second. Okay. Okay. We can decompose the velocity here in X and Y values because I suppose here will be important to use the X velocity too, right? So X equation, for example, for the X position, we have this equation here, right?
Yeah.
Yeah. So our velocity is 0 cosine, and in my calculation, will be 38.3 times t, right? Okay. This is for our X position. We are interested in position here, right? Because we
Yeah.
know we need know the position where the rock. Okay, so we have the X position. We have an X expression, and we have a Y expression too, because we have the information too. We use this value in another moment in a problem. So here we can use this this expression. I don't know. This is very boring. I will put only 4.9 here, right? And aqui, here, too. This is the Y expression. Do you agree with me?
Yeah.
Okay. So our hill have a slope, 20 degrees. So this is the expressions for the rock. This is the expression for the real. The real will be why this value here. I can I can show you because we have an expression like this: tangent of 20 times x. This is the expression to this real, right? Because
Yeah.
when we have a line, the angle with the line do the angle with the line do with the x-axis is our slope, is this term in the equation, right? If you take the tangent of this angle, right? The tangent is the slope. What's the tangent of this expression here? If you put this in your calculator, you will have 0.36, right? X.
Yeah.
Okay. This is the expression to our hill. But I can use this equation here to create one equation only. So I can use, in other words, this and this to obtain an expression for the real in function of time. Right? If I substitute this here, I will take an equation to the position in the real in function of time. Okay, so I have this, I will just copy. And here I will put this equation. So we can do the multiplication. We will have this, right?
Yeah.
Okay. Okay, amazing. So this expression is a interception using the information of the hill and the x-axis. But in this moment, we have two variables. So I cannot take any value here. I need more, one more equation. And one more equation can be this one, because these two equations give to us the position of the rock in some time, right?
Yeah.
So if I intercept these equations, or be these equations equal, we will have the time where the rock gets encounter this hill. Okay?
Mm-hmm.
So I suppose you know how solve this, because this is a quadratic equation, so you can use the quadratic formula, right?
Yeah.
Okay. So can you do this for me, please?
Yeah, no calculator.
Yeah, you can use your calculator. I think it's more easy. Will you have a test this week?
No, I don't know.
No? Okay. This is good. Because we have more time to learn this, right?
Yep.
Yeah.
Um,
I have a lot of students learn this in this time. This is a subject is very confusing sometimes because you need get informations in a dimension and put in other dimension. Do you understand? Like
yeah.
we do this, we get the things in X and put in Y to obtain the value in T. So three dimensions, three different dimensions here.
Mm, are you sure that's a quadratic?
Oh, sorry. You can use the quadratic formula, but it's not necessary because this equation is not a complete equation, right?
Yeah.
Only the complete equations you need use the quadratic formula here. You can isolate the t, the letter t. It's more easy. In other words, you can aggregate these two terms, right?
Yeah.
And after, you can isolate the t. So the expression is more easy to solve than quadratic formula. But you can do of your way. But I want a photo because I need to know how you write these things in your test, because I can do some hints to you.
I'm sorry, my brain is very tired. I've done a lot of stuff today.
But are you doing this, or are you having some difficulties here?
Yeah, I haven't done math since math that isn't, just physics since before summer. So I'm just like, you know, rusty.
Just try, man. When you finish, you can send to me, right? If you are wrong, not problem. Because I need to know where you don't know how do you like that. Do you know? Because for me, it's very important.
Yeah.
Understand what you don't know. If you have something, just send me.
Give me a second.
No problem. If you want, I can do this to you.
No,
No?
I just finished. I think it's
Okay.
wrong, but
No problem. Let me see. You have a lot of things here,
Yeah.
and you obtain this. I don't know. This value is different for my value. Okay, so I will do this. But your idea is right. You need isolate t here, so you can take these values and equal 0. So you have this, and you divided 46 for 5. And I don't know, these values is strange. But okay, I will try here, okay?
Wait,
So
so how did you do it?
I suppose you is wrong in one problems only. When you do this negative math here. So
Oh, right. Yeah.
we will have
I forgot about that.
32.1 minus 13.94.
So it's
T
18.
equals 0. So I don't know how much is this, but I suppose it's just a second. Because I am not good today in math too. in simple math. I need to use my calculator to do this because
It's
I'm very lazy today.
18.76.
Sorry, how much?
18.76.
Yeah.
Oh, no, wait. Hold on. No, maybe.
18.17. 18.1.
16. Yeah. Oh, because I read it as I read the 1 as a 7.
Okay. So you understand your mistake, right?
Yeah, yeah.
Okay. This is the important to me. I show to you where you are wrong. Okay. So right, the another things is right. Okay, this problem is only this, right? Your I saw you have math problems, not physical one. Okay? Because physics is only interpretation. When you interpret the physics of your problem, the physics is finished. After the math starts,
Yeah.
right? So we have math problems here. Okay, but okay, we did. Do you have another thing to us do now? If you don't have it, I can search something to you. But
yeah, I don't really
my
I
book,
thought this would take
yeah, my book is in Portuguese, but I will write the things in English to you. I will just translate the things, and I will write the things too. For example, here we have horizontal launch. Okay, just a second to open the page. Right here, this is the most common situation. We have a plane. The plane launch something where this thing will encounter the floor. Okay, this is very normal, a normal problem. I will just just pick something, some situations here. Here, the book first do the equation of position in y, okay? Because they say they say about the height of this situation. 720 meters. So we know this height, we know the gravity, we can get the time here. So we discover the time is 12 seconds. So 12 seconds to down, but 12 seconds to go to right.
Yeah.
In same time, right? So we can use this time in another dimension, in the x dimension. But in x dimension, we don't have acceleration. So we can use a more simple equation to solve the problem. The equation, the position equation, where we don't have acceleration. So we can put the value here and the velocity here. But which velocity, right? Our problem say to us the velocity of the plane is 15 meters per second. But
so that's the initial
theory, the velocity of this thing is 15 meters per second too, right? Because the velocity of this thing is the same of the plane, at least in x dimension, right? Because in x dimension we don't have acceleration. So the velocity of this thing is ever 50 meters per second. Okay?
Yeah.
So we can use this velocity here, put the time here, and okay, we get the value of the how much meters this thing get in this problem, right? So we have a problem very similar here. I will translate this to you. Just a second. I will put the figure here. This figure is easy to understand. It's a similar situation. And just a second, I will translate this. Just a second. Okay. I really need to understand if you can get this problem. You can solve this problem, right? So can you read this? This is big enough to you?
Yeah.
Okay.
Yeah, I can read
So
that.
I suppose you can solve this first problem. Okay?
Yeah.
So you can do this in your note and send a photo to me, right? Just the problem A. Oh my God. This is in Portuguese. Just a second. I copied the wrong file. Oh my God. Okay, just the A problem. If you have some doubt, just ask to me.
Okay.
But I prefer you do this alone first to me understand what's your difficulties. Okay?
Yeah.
What what are your issues in these situations? Okay. So send me a photo, right?
Yeah. Mm, it's still, even if it says 10 meters per second squared, it's still minus. Yeah.
Yeah, I
With the
suppose.
gravity. Yeah.
Here our gravity is 10. We can use 10. Okay?
Mm, Is the V0, is that initial velocity?
You need to say to me which dimension are you speaking about? Because this value here is to x dimension, right?
Yeah,
So
yeah,
this
but I use I learned it with like a different letters for, I learned it as U is initial velocity and V is final velocity, so it's a little confusing, but with the picture
okay,
next to
but
the
in this
plane, it
picture we
says
don't. But in this picture,
V0 equals 250 meters per second.
okay, right. I don't know if in your test you will have the same letters. So you need to understand and interpret your problem, right? Okay, but of this velocity, if you saw this picture, the velocity is a x velocity, right?
Yeah.
And in this problem, in another problem, in any problem, in x, we don't have acceleration. So in x, the velocity is ever the same, is ever 250 meters per second. Okay? So in x,
Yeah.
we have a uniform move, right? Our equation is this. In y, we have acceleration because we have the gravity. So we can use in this problem our y-axis to obtain the time, right? Because in y-axis, we have more information. We have the displacement and we have the gravity. Our velocity in y, our initial velocity in y is 0 because the package was released. If the package was released, the package is not launched. So the velocity is 0 in y, right?
But in X, it's 250. Yeah.
I don't know. I really don't know the values, but you can use this equation more more simplify, right? Because I don't know, your initial position is 0 because here is 0. I don't know. Or here is 0. You decide this. The velocity is 0 too. So we have only this term to obtain the displacement. But now we want the time. So 2000 here.
Yeah.
10 here. And you can do the square root, right? And you obtain the time. How much was your time?
Well, I'm gonna do the calculation now.
No problem. You can send me a photo, right? It's more
Yeah.
easy to me understand if you understand too. have another class now.
Oh, okay.
So
Well, I send
you
it to you. I
yeah,
send it to you after.
you can send to me in the WhatsApp. But today the class was amazing. It was really interesting because this subject is very cool to me because I am a physicist. So I really want help you if you have more doubts, right? If you have
Okay.
more issues in physics, just send me a message, right?
Yeah.
I
all
am
right.
sending the things we did today, and when the